Okay, now we have a circle. This is a circle. This is the center of the circle. You already know what the radius of the circle is. This is the radius r. The diameter is any line that passes through the center and touches the two ends of the circle. Then the radius again is the half of the diameter. So now any line that is not a diameter that passes inside the circle and touches the two edges, we call it a chord. That's a chord. Then a chord leaves an arc. This is an arc, the arc of the circle. An arc. And between the arc of the circle and the chord, we have what we call the segment, the area I'm shading now, segment. So now a sector is formed between two radius and an arc of a circle. For example, this is a sector. There's always a center at the sector that formed an angle theta between the two radius. This is also a sector. Maybe this is another angle, r phi. So you notice that this sector is divided into a major sector and a minor sector. Now, a major sector has this theta. The minor sector has this angle theta. If I want to find the major sector of this, that means that we are going to have an angle that encompasses this. So that which will be 180. 180 minus theta. 180 minus theta. So we always pay attention when we are talking about a sector. We pay attention to whether it is a major sector or a minor sector. The same thing happens to the arc, major arc and minor arc. Even segments, we have the major segment and the minor segments. Now, the circumference of a circle is given by 2 pi r. That's the circumference. The perimeter of a circle is given by 2 pi r. So anytime we are calculating the length of an arc, let me say this is arc AB. This is arc AB. So anytime we are calculating the length of the arc AB, we are going to use the formula length of arc. We say length of arc is equal to theta divided by 360. Then times the circumference, perimeter of the circumference, 2 pi r. Please take note of that, very important, times 2 pi r. That is whenever we are calculating the length of an arc. And whenever we are calculating the area of a sector, the area of a sector, remember, the area of a circle itself is given by pi r squared. So whenever we are calculating the area of a sector, we use this pi r squared. That's area of a circle. So area of sector is given by theta divided by 360. Then times pi r squared. Very, very important. Very, very important. So now that's for the length of arc and the area of the sector. Let me redraw this here. If you have this is what we are talking about. This is the sector. That is the sector theta. And the arc AB. So center of the circle is O. So the sector is sector AOB. Now, from what I have just drawn, if I draw a line between A and B, I'll form a chord. That line is called a chord. How do we get the length of that chord? How do we get the length of that chord? Length of the chord, AB. Length of chord, LOC, length of chord, is given by 2r, then sine theta over 2. This is the formula we use to get the length of chord. Once you know the radius of the circle, and we know the angle at the center of that sector. So the length of the chord that is formed inside that sector is given by 2r sine theta over 2. Now, between this chord and the arc AB, we have the segment. This is the segment. Now, that is the segment. So now, to get the area of that segment, we call it area of the shaded portion. Area of the shaded portion of this is gotten by. Now, let me open your eye to something. If you look at that diagram now, after we have separated the segment, after we have shaded the segment, you notice that there are two shapes that are obtainable there. Now we have a triangle AOB, triangle AOB. We also have the sector AOB. The triangle is between the radius and the chord, while the sector is between the radii. Sorry, not radius, radii, because there are two radius there. That's the radii and the sector, sorry, and the arc. Let me repeat. The triangle is between the radii and the chord, while the sector is between the radii and the arc AB. So for us to get the area of the segment, that is area of the shaded part, we simply need to get area of the sector. When we get area of the sector, we subtract area of the triangle from area of the sector. That will give us area of the segment. Now, the big question is, how do we get the area of the triangle? Remember, we have three major ways to calculate the area of a triangle. The first way by which we can get the area of a triangle, we have half base times height. When we are given a triangle with base and height. Then the second part is when we are given the two sides of a triangle and an angle which those two sides bound. We use half AB sine theta. Half AB sine theta. Then the third one is the hero's formula. We call it the hero's formula. That hero's formula is a situation whereby we have the three sides of a triangle. The three sides of a triangle, A, B, and C, which we use to get the semi-perimeter of that triangle. So that with that semi-perimeter, S, we can say that the area of the triangle is square root of S into S minus A into S minus B, then into S minus C. Remember, I've mentioned that S is the semi-perimeter. Semi-perimeter is A plus B plus C divided by 2. Then, after we get the semi-perimeter, we can now use the semi-perimeter and the formula given here, S into S minus square root of S into S minus A into S minus B into S minus C to get the area of the triangle. Very, very important. So now in this question, which of these are we going to utilize to find the area of the triangle in this? It is obvious that all we need to do is to use half AB sine theta, because we have the two radii as our A and B, and we have an angle theta. So area of triangle is going to be equal to half AB is our R times R, AB, because the A and B is presented by the two radii. So this is half R squared sine theta. Simple. Then now, area of the sector, which is, I think we have done that before. Area of sector is going to be equal to theta over 360 times pi r squared. So now this gives us with these two areas. Now we can now calculate the area of the sector. The area of the sector AOB, which is area of the segment. Area of the segment, that is the area of the shaded portion, is going to give us area of segment. Area of segment. Area of segment is now going to be equal to, remember I said that is area of the sector. Area of the sector, which is theta over 360 times pi r squared. Pi r squared. Then minus area of the triangle, which is half then r squared sine theta. Half r squared sine theta. So with this, we have gotten the area of the shaded part, which is area of the segment. Now to keep it all, remember that you will always be faced with some confusing questions that might be demanding you to get area of major sector or area of minor sector. How do you really know? Anytime you see a question that say find the area of the sector, most times the diagrams are labeled. Then when they are not labeled, if major sector is not, if major is not included, you always take it as minor sector, and also it will be very clear given the angle that will be provided for you. So this is just a rundown of how we go about all this. Then remember, another important knowledge in circles is the conversion from degrees to radian. Degrees to radian. Remember, we say that pi radian is equal to 180 degrees. Very, very important. It's an important conversion. So anytime you are given an angle to convert to radians, or you are given a radians to convert to degrees, all you need to do is to remember that pi radian is equal to 180 degrees. For instance, if I want to convert 60 degrees to radians, all I need to do is that 180 degrees gives me pi radians. Then 60 degrees is going to give me 60 times pi, then divided by 180 radians. That's what I'll have here. So this one and this one, this one and this one, this will be 3. So remember that this will simply be, that will be pi divided by 3, pi over 3 radians. And that's it. So now everything about what I've just discussed now is very, very important for you to crack some important questions in SAT. So now let's look at some important questions based on this.